Alright guys, welcome back to Underground Science. In this video, we're going to be continuing to talk about alkanes from our previous video. Okay, so in our previous video, we went over the basics, which was identifying, what alkanes are, knowing that ane suffix means alkane, which is just a hydrocarbon chain, right? And we went over some examples. In this video, we're going to continue on that, right, on alkanes, and start talking about branches. So the branches that we're going to be talking about is basically going to be related to the basic alkanes that we went over in the last video, right? Which was methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, right? We remember those 1 carbon through 10 carbons, right? And so those can also be branches off a parent chain. So what I mean by that is we're going to represent parent chain by saying R, okay? So it's some parent chain. And we'll go over parent chains and actually naming alkanes in the future videos. But right now, let's just denote R with a circle as a parent chain. And if I draw a branch, right, let's say I draw that, and I ask you what this branch right here is called, right? So if with the knowledge of our previous video, we would say that this, because that this, what we boxed in, has only carbons. So remember, these were carbons right here and here, and hydrogens, which are imaginary, right? So 2 here, 3 here, because carbon can only have up to 4 bonds. If we just looked at that, we would say, okay, this boxed molecule, which is a branch of this parent chain, is ethane, right? Based on our previous video. But because it's a branch off a parent chain, right? So this is the parent chain, it's a branch off of it. It wouldn't be ethane, it would actually be ethyl, okay? Ethyl. And so look what we did here. We changed ane as a suffix, but we changed that to ill. But we kept everything else the same. And that's the only thing that you have to pay attention to. That's it. And then it's the same for everything else. So if you were to do another example, let's say this is our parent chain, and off the parent chain we have a branch like this, right? So based on the knowledge of what we did in the first video, just the basics of alkanes, right away we'd be like, okay, this branch is a hydrocarbon. That's all it has is hydrogen and carbons. Everything is single bonds. Because a reminder, right? Ane, if you see ane, what do you know? It's alkane, and this means that there's no double bonds. And or triple bonds for that matter, or triple bonds, right? And the reason why I say this is because in the future we'll see that ene, right? Ene, so we can even write this right now, but we won't go into it right now. Ene signifies an alkene, which means that you would see double bonds. Okay, so this right away you know, okay, I need to look for double bonds. And similar to that, if you looked at the suffix "-ine", that would mean, okay, I need to look for triple bonds. But we'll go over all that in our future videos. Okay, so for now, let's just focus on what we were talking about. So let's go to the next page so we clear all that out. So where were we? We're at this parent chain with 3. So based on our normal knowledge, we'd be like, okay, so this right here, this branch is an alkane, right? Because it's just hydrocarbons, no double bonds, no triple bonds, and it's 3 carbons. It's 1, 2, 3. So what would we say originally? We would say, okay, this is a propane, which would be right if it wasn't branched off of this parent chain. Because it's branched, remember, we changed the ane to ill. So what would that be? This would be a propyl or propyl branch, right? You wouldn't say it's a propane branch, you would say it's a propyl branch. And if you want to do one more example, we can go 1, 2, 3, 4, 5, right? So normally you'd be like, okay, I mean, I think you guys get the point now. Normally you would say this is a pentane molecule. However, it's branched off a parent chain, so it'd be a pentyl. It would actually be, right, a pentyl. And again, we changed the ane to the il. All right, so I think we got the point there, right? So like if we did one more quick example, this would be the parent chain, and if we drew this, right, looking at just the branch, we would say, okay, this is 1, 2, 3, 4, 5, 6 carbons, so this would be a hexane, right? But because it's branching off a parent chain, again, you change the ane to a il, and then you would get hexyl. Okay, so it's a hexyl branch. And just like that, you can do that for all the basic alkanes that we learned. Okay, so you would just to list a few out, you could draw methyl branches, which would just be like this, right? So this would be a C bonded to 3 H's. So a CH3 branch off a parent chain is methyl, and then same thing you could say for ethyl, which would be R and 2 carbons off the parent chain. So this would be 2 carbons, so this would be RCH2 CH3, right? Because this is 2 hydrogens here, 3 hydrogens here, because each carbon has to have 4 bonds, and so on. So you can have a propyl group, butyl group, pentyl group, hexyl, heptyl, and so on. But that's not the only, those aren't the only branches that we have to worry about, because those are just basic branches, right? Like if you have a propane, right? So like, again, if you have 1, 2, 3, that's 3 carbons. This right here is propane, and we already know propane, right? We're really familiar with the basic anes. And so if you know propane, you just change that, okay, that's a propyl branch. But there's also other unique ones. So if I drew something like this, right? So again, you go to the basics. What do we know? Okay, how many carbons is this? 1, 2, 3, right? This is the branch. And if it's 3 carbons, we know it's propyl. Okay, and that is correct. But here we have to be more specific. Okay? Well, you can start by saying it's propane, but because it's off a parent chain, you would say propyl, right? But that's still not right. You have to be more specific, because this carbon right here, which is branched off the parent chain, is branched again into 2 bonds, right? I mean, it's not like split into 2 bonds. I'm just saying like this carbon bonds again to 2 other carbons. And so that would mean that this is an isopropyl group. Okay, it's not a propyl group, it's an isopropyl. And so you can do the same with other examples too. So if we went to another example, this is the parent chain, that's an ugly R. If this is a parent chain and I drew something like this, right? So first step, okay, how many carbons is this? 1, 2, 3, 4. All right, so what does that mean? That this is, I mean, originally you would say, okay, butane, because we're talking about alkanes. But remember, we're talking about something that branches off a parent chain. So it wouldn't be butane, right? It would be, here, let's erase this. It wouldn't be butane, it would be butyl. But that's still not right, because remember, we just went over it. What's this? That's an isopropyl branch, right? Well, don't these seem a little bit familiar? I mean, a little bit similar? The reason is because you have a branch off the parent chain, and then you have another 2 bonds or 2 branches. Same thing happens here. You have a branch off a parent chain, but this is 4 carbons. So you have another carbon here, right here, and then this carbon branches twice, just like the isopropyl one did. So this would be not butyl, right? Let's make some space here. Hopefully you guys guessed it. It wouldn't be butyl, right? It would be isobutyl. So this is called an isobutyl group, while this is called an isopropyl group. Okay, so next, let's go and review something else. So we have a parent chain here, right? And then I'm going to draw this. So normally, right, if I drew this, what would you say that is? What branch, what's the name of this branch, right? So you'd say 1, 2, 3, 4. I'm numbering the carbons here. 4 carbons, it looks like an alkane, so it's a butane, right? But again, it's branching off the parent chain. So it wouldn't be butane, right? It would be butyl. Okay? That's what we would normally say, right? Because it's 4 carbons and it's branching off the parent chain. But what if I drew this? So I'll draw this, right? So that's 3 carbons, but then I drew a 4th carbon like that. So what would that be? So you would again say, okay, let's number the carbons. 1, 2, 3, 4, right? This whole thing comprises of the branch. Okay, so you're like, okay, this is butane, okay, right? But then it's off a parent chain. It's a branch off the parent chain. So you can't say butane since it's a branch. You have to say butyl, right? Which we've gone over many times. But that still wouldn't be right because this is a unique butyl branch. It's actually called a sec-butyl, okay? And so let's try to make more space for that. Let me write that down right here. Sec-butyl. And that might sound odd at first because sec actually stands for the full form, which is secondary. Okay, so what does a secondary butyl mean, right? If you see here, there's 4 carbons, right, on the branch, which is butyl. So we got that. The secondary denotes this carbon. If you pay attention here, this carbon is called a secondary carbon. Okay, now let's deviate for a moment and talk about what primary, secondary, and tertiary carbons even are. So let's quickly say right here, primary, secondary, and tertiary. Okay, primary carbons are carbons that are bonded to only one other carbon. So an example would be ethane, right? And if we just drew the blue lines are hydrogens, okay? Like it's just imaginary hydrogens, but let's not write it out for the sake of time. So ethane, if we focus on this carbon right here, how many other carbons is that carbon bonded to? Right? And the answer is only one other carbon. So this carbon would be a primary carbon. Right? And if you want an actual line diagram example, if we drew a line diagram like this, and I said, what level carbon is this? This would be a primary carbon. Right? Remember these are the carbons in a line diagram. So if I said this carbon is bonded to one other carbon, that's why it's a primary carbon. Secondary carbon, if we just went straight into a line diagram example and actually used the same one, if I said, what level carbon is this? Right? You would say this is a secondary carbon. And why is that a secondary carbon? Because it's bonded to 2 other carbons. 1, 2, right? So this carbon right here is bonded to 1, 2 carbons. That's why it's a secondary carbon. And by now you should know, or you probably figured out that what a tertiary carbon would be. So if I drew this, right, this molecule, and I said, what level of carbon is this? That would be a tertiary carbon because this carbon right here is bonded to 1, right, this, 2, 3. 3 other carbons, so that's a tertiary carbon. So that's primary, secondary, tertiary. And of course, quaternary would be 4 other carbons. But we come back here, that's why this is called a sec-butyl, because this carbon right here is bonded to 1, 2 carbons, so it's a secondary carbon. All right, so now we've went over, let's review now. All right, so if I drew this real quick, what would that be? So that would be an isopropyl, right? And very quickly, why? Because there's 3 carbons, so that's propane. But because it's a branch off a parent chain, it would be not propane, but it would be propyl. And because it's a unique propyl, because this carbon also branches, it would be an isopropyl, which is what we wrote here. Okay, now if I drew this, right, this would be an isobutyl. Hopefully you recognize that pretty quick, because 1, 2, 3, 4, right, so that's a butane. But because, again, I know it's repetitive, but it's important we get this, it's a branch off a parent chain. So that's not butane, it would be a butyl. And because this branch kind of looks similar to this branch in terms of this carbon branching out twice, right? This carbon branching out twice, or you would also name this isobutyl. And then let's go to our other example that we covered, which was that, right? So again, what would this be? Immediately be, okay, 1, 2, 3, 4, butane, but it's a branch off a parent chain, so it's not butane, it's butyl, right? And another thing, it's a unique butyl because this carbon right from directly off the branch of the parent chain is what? It's a secondary carbon because it's bonded to 1, 2 carbons. So it's not butyl, it's sec-butyl. Okay. One last one that we should know is off the parent chain if you see this. So right away we would identify, okay, there's 1, 2, 3, 4 carbons, that's butane. And by now it should be ingrained in your head that, okay, this is a branch off a parent chain, so it's not butane, it's butyl. Let's write that U a little bit, or the whole thing a little bit better. Butyl, all right? But it's not a normal butyl, right? So immediately, I mean, you can, this looks like a T, right? It's just a normal T, a sideways T. And so that's why it's called T-butyl, right? Or another form that you can write it, which is also common, which is tert-butyl. Now, why is it called tert-butyl? Well, we went over this. What's a tertiary carbon? Right here. Why is it tertiary? It's connected to, or it's bonded to 1 carbon, 2 carbons, 3 carbons. So this carbon, the central carbon, is bonded to 3 other carbons. That's why it's called a tert-butyl. This whole branch is a tert-butyl because this is the tert, or tertiary, and then you have 1, 2, 3, or 1, 2, 3, 4 carbons, so that's butyl. So together it's called tert-butyl. Okay, and so those are the main branches that we should know. And in our next video, we'll start talking about alkanes, but it'll be more specifically cyclic alkanes. All right, so that's it for this video, and I'll see you guys in the next video.